Okay, so this is a quick going over of the stages of evolution. So first of all, if you want evolution to occur, you need some genetic variation in your population. So if we're talking about bacteria, it could be that you have bacteria that are all the same apart from one that has a plasmid as well as its own circular DNA, and that plasmid codes for a protein that makes it resistant to, for example, ampicillin, which is a type of antibiotic. And what will happen is, if a doctor prescribes ampicillin to the population of people, of humans that are carrying these bacteria, then all of these will die. So death when ampicillin, the antibiotic, is present. And it's only this one, this ampicillin resistant, that survives. So this random mutation has led to a new allele causing resistance to ampicillin, and it is only in the environment where ampicillin is used that it's any good. So if we went back to this original population here and we didn't have any ampicillin, so we got rid of the ampicillin, then it would be all of these bacteria that would survive, and actually this one would die. And the reason for that is, in order to synthesize that protein, it requires a lot of energy. That means that this particular bacterium reproduces much more slowly, and so it can't compete and it can't keep up with the reproduction of these bacteria that don't have to produce any protein that will help them against ampicillin, because the ampicillin doesn't exist. And so very quickly, over many generations, the allele frequency for the non-mutant increases. And that's how you prevent a population of bacteria that are resistant to ampicillin from arising. You stop using ampicillin, because if there's no selection pressure, which is the ampicillin, the use of the antibiotic, then you won't get selection for that original mutant. If you did use ampicillin again, then that mutant would reproduce, all its offspring would have the resistant allele. It would also be able to pass on that allele to other bacteria. And if that happened, then you really are in trouble. And this is how you can end up with populations of bacteria that are resistant to numerous antibiotics. And that's because if one of them develops a mutation that makes them more likely to survive, they are able to replicate their plasmid and pass it on to other bacteria. And this is how we develop things like C. difficile and methicillin-resistant Staphylococcus aureus, MRSA. So you can end up with bacteria that are resistant to multiple different antibiotics because they share their plasmids. But if you want to get rid of an antibiotic-resistant bacterium, then all you need to do is stop using that antibiotic. So doctors in surgery will often use their antibiotics in a cycle, and by doing so, hopefully, they aim to prevent any one particular type of resistance developing too far by not allowing the selection pressure to be present for too long. And that's basically evolution.